Hi everybody and welcome. Today we're going to be looking at a video that goes over some extra examples of systems of three equations practice. So I know that this will actually, I think, probably be like our third video on this topic, and I know it's a challenge, so I wanted to just have as many help resources as possible to kind of help us have a solid guide to go through. So before we start, to clarify a couple of misconceptions. So we have some goals here, and our goals when solving these are, first, we want to eliminate a variable. Something that I saw is that students might eliminate one variable in the first equation, so maybe you eliminate y in the first equation, but then in the second equation you eliminate something else. It has to be the same variable. So a tip for this one is has to be the same variable. The second goal that we have is to form a new system. So by eliminating a variable, we are forming a new system that has two equations and two variables. So that's our goal. So after we're finished solving this question, going through with eliminating, first we're going to, again, eliminate the same variable twice, and then second, we're going to form a new system that has two equations with two variables. And I think that we are in good shape. The final thing that we want to bring up is we must use each equation once. So again, must use each equation once. All right, so let's take a look. We have a choice now of which variable we'd like to eliminate. We can eliminate x, we can eliminate z, and we can eliminate y. If we look straight up and straight down, and I should label these equations first. We have equation 1, equation 2, and equation 3. We're allowed to eliminate any one that we want. It doesn't matter. It won't change our answer, but it might change how quickly we get there. Some of these might be a little bit easier than others to eliminate. For example, 5 and 4, negative 5 plus 4 gets us negative 1. That doesn't eliminate anything. But if we had 5 minus 5, for example, that does equal 0, and that would be something that eliminates there. So maybe that works for us. Another one would actually be positive x minus x. That's another option. So it looks like here we can either eliminate x or eliminate y. They both kind of lend themselves easily to do that. Now, I think the best path for us here is the y term. If you look, all three of these y terms are 5, which means we won't have to do any multiplication of the equations to eliminate it. For the x terms, yes, we can definitely eliminate them. But in order to do that, in order to get rid of our 4 term in equation number 2, and I'll highlight that in a different color, in order to get rid of this, we would have to multiply the first equation by 4. So a little bit of extra work there for us. So we're going to avoid that extra work, and we're going to eliminate y. So to be very clear, we are eliminating y twice. Okay, let's keep going. So put these equations together in an order that will eliminate that y. So use equation number 1. And we want to get rid of negative 5y. So the opposite of negative 5y is positive 5y. Do we see any of our three equations here that use positive 5y? It looks like number 3 does. So let's use that. So x plus 5y minus z equals negative 20. All right. So let's go ahead and let's eliminate. So negative 1x and positive 1x, that actually does give us 0x. And negative 5y and positive 5y, that actually also does give us 0y. And negative 5z and minus 1z gets us negative 6z. 2 minus 20 gets us negative 18. So we actually here eliminated 2 variables, and that's nice. The reason why is because now we have our new equation, negative 6z equals negative 18, and we can actually solve this. We can get an answer for z right away. So this is a nice equation because it saves us a little bit of time. Now that won't always happen, and that's okay. Sometimes when you get to this step where you have your new equation, you won't be able to solve it right away, and that's okay. But this one, again, it's a nice question. It saved us some time. So here we go. We have z equals 3. All right. So let's check our steps. Did we eliminate a variable? Yes, we eliminated y. Did we form a new system? No, we didn't yet. So we need 2 equations with 2 variables. We only have 1 equation here, so we need to eliminate y again. All right, so let's see. Again, same goal, eliminate y. And I'm going to look at number 3, must use each equation once. Okay, so we used equation number 1 and we used equation number 3. That means we definitely have to use equation number 2. 4x minus 5y plus 4z equals 19. Okay, so we've used equation number 2. And again, we're eliminating y, so to get rid of negative 5y, we need positive 5y. And let's look back again. Which equation do we see that has a positive 5y? Looks like we're going to use equation number 3 for this. We are allowed to repeat the use of an equation as long as we use all of the equations at least once. So yes, we do use equation number 3 2 times, and that's okay. We're allowed to do that as long as, again, 1 and 2 are also used at least one time. All right, so lining these up and straight down. 5x, 0y, 3z, and negative 1. So our new equation, we have 5x plus 3z equals negative 1. That's equation B. So now for number 2, our goal was to form a new system, 2 equations and 2 variables. So we have x's and z's, those are the 2 variables. A and b are the 2 new equations. So now we're going to go into our next step of this, and we're going to solve the new system. So our new system has A, which we simplified to z equals 3, and B, which we have as 5x plus 3z equals negative 1. All right, so substitution here is going to be probably the best play because z is already solved for. It's already isolated. So let's plug in 3 for z into equation B. And we'll get 5x plus 9 equals negative 1. We can subtract 9 from both sides, and we'll get 5x equals negative 10. So last step here, let's divide by 5 on both sides, and we'll get x equals negative 2. All right, so we're in good shape. We have z equals 3. We have x equals negative 2. So our last step is to find y. So because we've eliminated it in our new system, we got to go back to the original system here and pick one of these equations. So maybe we can pick equation number 3. So let's use this. We'll plug in our x and our z value into that equation, and then we'll be able to solve. So our final step here is to solve for y. All right, so the last equation, equation number 3, we had as x plus 5y minus z equals negative 20. We know x equals negative 2, and we know z equals 3. So time to plug those in. So negative 2 for x, 3 for z, and here we go, time to solve. So 5y minus 5 equals negative 20. Add 5 to both sides, and we'll get 5y equals negative 15. Divide both sides by 5, and we'll get y equals negative 3. So our full solution here we have as x equals negative 2, y equals negative 3, and z equals 3. All right, so I would say take a look at the other practice problems there, so 5, 6, and 7. See if you can go through and solve those, and follow the same steps here. Remember your goals as you're going through to solve. Our goal is to eliminate a variable. Our goal is to form a new system, and we have to make sure we use each equation once. As long as we're doing these things consistently, we'll be in good shape. All right, thanks for watching, everybody, and hope this extra video